as we've seen with functions, their return type can be implied based upon a single expression. So as long as a function just has one line and it is just one expression, then the return type can be used from that one expression. And that is the same for all closures as well, because functions and closures are basically the same thing. They just have a bit of a different syntax, that's all. So let's just go through this example here, and it nicely shows you, in my opinion, how you can do this. So we have a collection of scores here of integers, and then we have a collection of strings of students, okay? And then what we're doing is we're saying students, and we are saying enumerated, and that is converting it now to a sequence, right? And we are filtering through the sequence. So what we're saying is we only want students that their score is more than 70, all right? 70%, 70 points, or whatever. It's only more than 70. So every single index, so the 0 index is then 21, the first index is 88. So there's 8 students and 8 scores. So they're all in the correct order, all right? And so as it's going through all of the students, it's getting the item, which is the element in each. So it's getting the first element, and what's happening is this is basically a tuple. It's then saying the elements, right, first, followed by then the offset, all right. And this is basically then a string followed by an integer. So it's telling me, hey, what's the actual element here, and what is the offset of it. And when it goes through the first one, obviously Alice, this is going to be an offset of 0. And so we're going to say to the scores, give me the offset of 0 here on 21. And then we are going to say if that score is more than 70, we're going to keep it in this one array, and we're going to add it to past, all right? If it's not, we're going to skip it and going to ignore it. Now, because we don't have to give the return, using a return keyword, as long as we have a single expression, right? And it's one line. So we've been over this in the other videos, but if you haven't seen that other video, don't worry about it. This is doing the same thing. So our closure has an item here, which is an enumerated sequence element, right? And we are then, this is the same as us saying return this. There's no difference, but because this is just a single expression, we can remove this return keyword, and Swift compiler will imply it or infer it anyway, based upon, because it's only a single expression. And so the first element is obviously not more than 70. The second is, so this is one's going to be added to past. The third is not, the fourth is, the fifth is not, sixth, and so on. You can do it by yourself. And so we then have past. Now what we want to do is, because past is not an array of strings, past is a enumerated sequence of strings, okay? So we only want to have the names of the students, and that's it. So next what we do is we go through past and we say, hey, only give me the elements part of it, right? Remember, it's a tuple, so we only want the element part of it, and we are mapping. So we are converting the tuple to then just a string itself. And you can see here through type inference, we have then a collection of strings. And so, but there's no return keyword here, and we're using a different style here, and I'm going to get to this in the next video, but I just thought I'd give you an introduction to it right now. We're not even showing I'm going to get into another video. You're just going to have to trust me. And now we have an array of strings here, and so what we want to do now is we want to print out each item at the bottom. And so what we've got here is we've got results.forEach, and then we're going to say a print function. And so this print function has been inferred that it takes a type any, because it doesn't know, right? And we could tell it to be explicit to be a string as well. And now it would obviously know that it's taking a string and returning void. So this is basically the same as the type inference, the return. There's no difference between closures and functions returning their value, okay? But this just will give you a good insight to how you can write the shortest amount of code using closures. And closures get even better from here, and we are touching the surface of what they could actually do right now. But I just thought this allows you to understand that you don't have to use the return keyword, all right? And sometimes you don't even have to define the argument name as well. You can just use the sequence. So if it has then 3 arguments, then the first element would be then $0 and then $1 and then $2. So it's 0 indexed, okay? That's basically what's happening here, and so on. But map is no difference to here. So if we look at past and we say then map, you can see map is taking a transform function. So it's a function that returns the element. It's a generics. It's an element of type T, and so on. So it's nothing more than a high order function. And here you can see compact map is doing the same thing too. Flat map is doing the same thing. It's a function that returns a sequence and so on. So all we're doing here is if we write it out explicitly, it would be then map and then item and then here and then item dot elements. Whoops, sorry, we have to write it explicitly. We need then the curly braces and then in and then item dot elements. And if you want to be super explicit, then we'd have to do the return as well. All right, but we don't need to do that because this is basically what we can do here as well. We can go super short. All right. With that said, I hope that you got something out this one video. Like I said in other videos, I've known people to not being able to understand closures, and especially when we start talking about parallel programming, right, concurrence. This is where it's going to get a little bit more difficult. So you really need to understand that a closure is a block of code that can be passed elsewhere, all right? And a function is a named closure. A nested function is a named function within inside of another function or another code block. And so on. So this is what's really important. You need to understand these different rules and the different syntax and how you can use them. All right, it's so important. But I'm going to go over this really in depth until if you watch all of the videos to the end and maybe you repeat it, you will 100% understand this. I have no doubt whatsoever about that. So don't forget to like, subscribe, share, and do all the other social media things that are out there to do with these videos. And if you've got any questions, concerns, feedback, or anything like that, then I'm more than happy for you to ask a question and put it in the comment section down below. I will answer all of your questions and I answer all comments because it's a really a nice thing as well. Thank you for all the support. My name's David Thorne. Thank you very much for watching and see you in the next video. Ciao, ciao, and goodbye.